Hi everyone. In this video we are going to look at Newman projections, but I'm going to show you the three-dimensional structure for ethane and for butane. So let's start with ethane. Ethane has 2 carbons, which are shown in black, and 6 hydrogens, which are shown in white. And we first drew the structure so that we were looking at it from the side, but what if we flip this and look at it straight on? So we're looking down that carbon-carbon bond. So this is our Newman projection. We have 3 hydrogens on the front carbon and 3 hydrogens on the back carbon. And that's going to give us our first staggered conformation. Now, what if we rotate the back carbon 60 degrees? Because remember, if you have single bonds, they should rotate freely, at least at room temperature. All right, so if I rotate everything 60 degrees, we get our eclipsed structure here. So the hydrogens on the right are lined up, the hydrogens on the left are lined up, and the hydrogens on the bottom are lined up, just like in our picture. Of course, I draw these slightly offset so you can see where they are. And then we could turn the back carbon 60 more degrees, and we end up with our original staggered conformation again. So for ethane, we really only have 2 different types of structures, staggered and eclipsed. But it starts to get more complicated if we add different groups on here. So let's look at butane. So the way we drew it in lecture, we had 4 carbons, although I replaced the 2 methyl groups with blue atoms because it was a little bit easier. Methyl groups are quite large. So pretend these are methyl groups. So now we have a group that's different up here, one that's different down here. So now let's flip this. So we're looking down the carbon-carbon bond. Well, this gives us our first Newman projection. So you can see we have the methyl group on the back carbon there, and then the methyl group coming down on the front carbon. And then we have our 4 hydrogens surrounding those. So now what happens if I rotate the back carbon 60 degrees? Okay, well now I have this structure where this CH3 group here is lined up with the front hydrogen. This back hydrogen here is lined up with the front methyl group, and then the other 2 hydrogens are lined up over here. So this would be our eclipsed conformation, or one of the eclipsed conformations. So now let's rotate this 60 degrees again. That gives us our 3rd Newman projection. So now the 2 methyl groups are approximately 60 degrees apart here. And this is what's called a gauche interaction, because you have these 2 methyl groups offset from each other, and they would rather be opposite each other. And actually an interesting thing is the term gauche means left in French, but left-handed people were seen as being evil or sinful, which is silly. So now we refer to things that are, you know, maybe not favorable as gauche. And that's kind of where this term came from, is a gauche interaction. So I'm sorry if you're left-handed. Hopefully nobody thinks that way of you anymore. All right, so let's do another 60-degree turn. All right, so that gives us our 4th structure. So the 2 methyl groups now are lined up together perfectly, and all the hydrogens are lined up above, on the left and the right. Now let's do another 60-degree turn. That's going to give us our 5th structure. So now the methyl groups are again experiencing that gauche interaction. So this is very similar to our third structure. And then finally, if we rotate this 60 degrees, we get our last Newman projection, where the back methyl group is lined up with the front hydrogen on the left, and the front methyl group is lined up with the back hydrogen. Okay, so remember that all of the eclipsed conformations are less stable than the staggered conformations. And in fact, if we look at the most stable conformation, we call this anti-periplanar. So the two methyl groups are anti from each other, or opposite from each other. And then if we look at the least stable conformation, that's this one. So we call this syn-periplanar because the methyl groups are lined up with each other. All right, so I hoped that helped you a little bit with visualizing what's going on three-dimensionally. I know it's hard to visualize things when we just draw these two-dimensional structures. Now, I highly encourage you to buy a modeling kit. You can find them used online if you don't want to spend too much on them, but they will help out a lot in this class, especially if you have trouble visualizing these two-dimensional structures. All right, I will see you in the next video.